Okay, good evening, children, and all the best. And here I'm trying to give some important formula regarding some basic topics in first year kinematics. In that first already we discussed some topics which is motion in one dimension. In motion in one dimension chapter, we already discussed about distance and displacement, which are very easy and no need to worry about these two particular topics. But the one thing that it is, distance by displacement always greater than or equals to 1, and displacement vector equal to x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. This is one of the formula. And next, another important point here, the velocity equal to rate of change of displacement, nothing but differentiation. If you want to find velocity, then you should do the differentiation of displacement, and we find displacement equal to integration of the velocity with respect to time. Sometimes they will ask that they will ask a question like s equal to, for suppose x equal to at minus bt square, find find velocity. Find velocity means dx by dt we will do, a minus 2bt we can do. This one is the velocity. And next, sometime they will give velocity equal to at minus bt square, and they will ask us to find displacement. What is the displacement? Then s equal to integration of v dt, which equal to integration, which we can write it as at minus bt square, and the answer will be at square by 2 minus bt cube by 3. This is the integration answer. If the boundaries are there here, t1 to t2, you can substitute the boundaries. If not, it is plus c. And you know that one. And the second one, acceleration equals to rate of change of velocity with respect to time. This we write d by dt of, where velocity we already know that ds by dt. So finally we write d square s by dt square is nothing but second differentiation of the displacement is called acceleration, and where the velocity equal to integration of acceleration with respect to time. Here one of the very important question which they asked in the last 2019 also, that for suppose x equal to, we had a question that it is 2 square plus 3t plus t cube is there. Find acceleration when velocity becomes 0, or find velocity when acceleration becomes 0. This type of question. First you have to find, for this first one you have to find velocity dx by dt. For this purpose the answer is what? 4t plus 3. 4t plus 3 you got answer, or else if you are taking here minus 8t for simplification, 4t minus 8 you will get. Then they are asking acceleration when velocity equal to 0, then put velocity equal to 0, then t equal to, you will get 2 seconds. Now you find acceleration dv by dt, which equal to what you can write, 4t differentiation is what? 4, which is independent of time, so not changes with respect to time. We can write directly 4. For suppose you had x equal to 2t cube minus 12t, then v equal to what you write, are 6t square minus 12 we will write. If velocity is 0, then t value equal to 2 seconds. Then find acceleration, that it is 12t. Put t equal to 2 seconds here, 12 into 2, which is equal to 24 meter per second square. That means this is the acceleration when velocity becomes 0. It means one of the very important point, that particle may had zero velocity with non-zero acceleration instantaneously. That is a very important point. And similarly the same way you can solve this model of question also. And here one of the very important point, that it is the important point. For suppose we had equation A equal to dv by dt, but they given the equation V as V is a function of displacement, like V equal to 2x square minus 3x is there. Then they will ask us to find the acceleration in this case. If velocity is a function of displacement, then A equal to dv by dt, we can write it as dv by ds into ds by dt we can write. Then A equal to, simply we write ds by dt is what we call velocity. So A equal to V into dv by dx. This is the way you can calculate the acceleration when velocity of the body is the function of displacement. And here another important case, that it is, we all know very well about the equations of motion. Before going to that, average speed, which already I explained in the classroom only. Average speed equal to total distance by total time. Here we can write this is s1 plus s2 so on by t1 plus t2 plus so on. This is average speed formula. And here some cases are there. One first case, one it is, if distance not given, we had a speed v equal to s by t, then s equal to vt we can write, or t equal to s by v we can write, such that the average speed when velocity and time is given. So what you write is sigma vt by sigma t we can write. For suppose this S1, because here S1 equal to Vt, V1 T1 plus V2 T2, that nothing but sigma Vt by sigma T. For suppose here second case, if all time intervals are equal, if all time intervals are equal, if time intervals are equal, then what you can write this V average equal to T into sigma V by, when sigma T will become NT, TT get cancelled, sum of the speeds by number of the speeds when time intervals are equal. For suppose let assume the case where there is no time and displacement, distance and speed values are given, then we can write this is s1 plus s2 plus so on by s1 by v1 plus s2 by v2 plus so on. This is the formula. And here one of the very important, if displacements are equal, distances are equal, then the case n equal to 2 means we write average speed equal to 2 by 1 by v1 plus 1 by v2, nothing but 2 v1 v2 by v1 plus v2. This is the one. And average speed when 3 n equal to 3 means 3 by 1 by v1 plus 1 by v2 plus 1 by v3 equal to 3 v1 v2 v3 by v1 v2 plus v2 v3. That's of course sigma v1 v2 you can write, which already you know very well. And here one of the very important question which is based on this particular application is, a body is started so that 1/3 of the distance with speed v1, remaining 2/3 of distance with speed v2, it traveled. So basically here 1/3 of the distance means s1 equal to s by 3 we can write. 2/3 of distance means 2s by 3 we can write. Here time values are not given, so average speed equal to, you would write it is s1 plus s2 by s1 by v1 plus s2 by v2. And you can write this as what, s1 plus s2 is what, s by 3 plus 2s by 3 is equal to s only, s by, this is s by 3 v1 plus this is 2s by 3 v2. This 3 LCM is s by, LCM is 3 v1 v2. Anyhow here v1 is there, so v2 you would take, that by v2 we can write plus 2 v1. And here s is taken common, ss get cancelled, 3 v1 v2 by v2 plus 2 v1. But like this means it takes a lot of time. The shortcut method for this one is, see here first displacement is s by 3 with speed v1. This is shortcut method, okay. And second displacement is 2s by 3 with speed v3. Now average speed means simple, s by 3 plus 2s by 3, okay. Here you just take this one. What is the common denominator here? 3 we can write. What are the velocities or speeds? v1 v2 by, next the v2 into numerator here is what, 1s, so v2 plus v1 into your numerical number in the numerator is what? 2v1. So this is the answer. For suppose you just see, I will say one more example. Here a body is moving so that 2 by 5th of distance is with speed v1, 3 by 5 of distance with speed v2. Average speed is what? Now in this case, average speed equal to common denominator is what? 5 v1 v2 by next what is the numerator here? 2, this 2 into v2, 2v2 plus this 3v1. This is the answer. So very simple way you can solve this kind of questions. And next here one of the another important model of question they will ask here. That another model is a particle is moving such that first half of the distance is with speed v1. In second half distance, first half time it is v2 speed, second half time it is v3 speed. So overall average speed is how much? This is the question. See, first half distance with speed v1. In second half distance it had two speeds which are in equal intervals of time. So let you take this is the ABC. Very simple way we can solve. First you take from BC. So for BC we will write average speed which is nothing but V naught. That I am writing equal time interval means sum of the speed by number of the speed. So V2 plus V3 by 2. Just completed. Then next from A to C you take. If you are taking from A to C, A to B displacement is equal to B to C distance. So that is why what you can write here, average speed equal to equal distances and two speeds are there. B to C, what is the speed? V naught. So 2 V1 V naught by V1 plus V naught we will write. Now 2 V1 V naught value is what? V2 plus V3 by 2. 2 get cancelled by V1 plus V2 plus V3 by 2 we can write. So if you are taking LCM again, so V1 V2 V1 of V2 plus V3, this 2 goes to numerator 2v1 and this we write 2v1 plus v2 plus v3 simply we will write. And no need of using this particular formula also. Here just now I told shortcut method that it is s by 2 distance is with speed v1, remaining s by 2 distance is with speed v2 plus v3 by 2. So that here common denominator is 2, v average we need to find. Common denominator is 2, 2 v1 v2 v3 by 2 by this v1 into here numerical is what? 1 by 2, here 1 by 2. So v1 plus v2 plus v3 by 2. So again you will get same answer 2 v1 v2 v3 by 2 v1 plus v2 plus v3. This is the model. And here converse of this particular question, that question it is, for suppose the body is moving from point A to B such that first half time it traveled with the speed v1. In second half time it had two speeds v2 and v3 to cover the equal distances. So here also you can write from C to B simply that v naught equal to 2v2 v3 by v2 plus v3 because here distances are same. Now for complete journey AB, V average equals to VA equals to, as time intervals are equal, sum of the speeds by number of the speed. V1 value, anyhow V1 only, V0 value you got it is 2v2 v3 by v2 plus v3 whole by 2. So the answer is what you can write here, v1 v2 plus v3 in plus 2v2 v3 2 of v2 plus v3. This is the answer which you got for this kind of model of questions. And next here sometimes they will ask you to find average acceleration equal to a average equals to total change in velocity by total time. We can write total change in velocity. Sometimes change in velocity equal to we will write a1 t1 and delta v2 equal to a2 v2 because a equal to delta v by t. So this is the formula. With this we can write like this. Then average acceleration equal to a1 t1 plus a2 t2 by what you write t1 plus t2 we can write. And after this particular concept, here one of the another important point that it is, here we can write acceleration equal to 0 for constant velocity, nothing but uniform motion. Let sometime, most of the time they ask it based on this one question based on this concept, that it is a particle is moving with 36 kilometer per hour uniformly. If they said uniformly, ultimately you have to consider it is constant, so that acceleration equal to 0. And second important point that it is, in this case which is need to remember, that particular point is average velocity may 0, but average speed never be 0. This is the one of the important point. For suppose a particle starting from a, again reached b, again reached a only, so in this one total displacement equal to 0, such that total average velocity will be 0, but average speed and the total distance never become 0. For suppose a particle is in circular motion, I already told this particular formula. A particle is moving from point A to B, At A, its position vector is R1 vector. At B, its position vector is R2 vector. But modulus of R1 vector equal to modulus of R2 vector equal to radius of the circle. Let consider the particle is moving from A to B. Then the angle subtending at center is theta. In this case, distance equal to length of the arc L into theta. D equals to length of the arc equals to r theta, where theta must be in radians only. D equal to r theta. And next here displacement equal to, we write 2r sin theta by 2, because displacement equal to final position vector minus initial position vector. During the subtraction of two vector, if magnitudes are same, then the resultant equal to 2r sin theta by 2. Here one most important point to note, that it is, if modulus of a vector equal to b vector equal to x, then modulus of a vector plus b vector equal to 2x cos theta by 2, and modulus of a vector minus b vector equal to 2x sin theta by 2. If this modulus of a vector plus b vector equal to x again, then theta must be 120 degrees. If this modulus of a vector minus b vector equal to x again, then theta must be 60 degrees. And dot product, cross product, already we discussed that one. So this is the point which is need to remember. So by this total displacement equal to 2r sin theta by 2, then they will ask you to find average velocity also. Average velocity means what? ds by dt. So dr sin theta by d2 sin theta by 2 dt we can write it. 2r anyhow is constant. Differentiation of sin theta by 2 we have to take. Sin theta by 2 differentiation is cos theta by 2 into 1 by 2. So like that you can calculate the average speed also. So next another important point in this case which you need to remember, equations of motion v equal to u plus at, s equal to ut plus half at square. Sometimes you have to keep initial displacement also. V square equal to u square plus 2as plus or minus we will write here. Here also plus or minus. Plus is for acceleration and minus is for deceleration. Deceleration means if particle is moving such that acceleration is one side and velocity is one side, means velocity and acceleration are in opposite direction, then the acceleration is called deceleration. And one of the very important point here you need to remember, that it is, this is negative x-axis, velocity and acceleration both are acting. Acceleration is a vector quantity, here negative we will take, but both acceleration and vector are acting in same direction, so that this is not a deceleration. Here it is a deceleration. Now next one, Sn equal to u plus a by 2 of 2n minus 1. This is very important one. And next another important point, that it is total displacement for uniform acceleration equal to u plus u by 2 into t. This is the total displacement. And for suppose let you consider the case particle start from rest start from rest means what? U equal to 0, then V equal to at and S equal to half at square. So ratio of displacements when initial velocity is 0 in 1 second 2 second means 1 by 2 a 1 square 2 square 3 square 4 square like that. S1 S2 S3 1 square is to 2 square is to like that we can write. And next ratio of the displacements in first second third second means first odd number second odd number third odd number fourth odd number like that, so on we can do. This is about this particular case. And here a car is moving, a car started with an initial velocity u and travels at a distance s, suddenly brakes applied. When brakes applied, the car comes to rest, final velocity equal to 0 and the acceleration will be taken as the deceleration in this case. So v square minus u square equal to minus 2as we can take. V is 0, so minus minus cancel and u square equal to 2as. Anyhow a is constant uniform deceleration, so u square proportional to s. So that means s1 by s2 equal to u1 by u2 whole square. Sometimes they will ask car traveled some 300 meter when it started with 20 meter per second, what is the velocity to stop at 900 meter, like that means we have to use this one. And the stopping time also, retardation time, v equal to u minus at. When v equal to 0, then t equal to u by a, which we call as a time of ascent in vertical motion, but here t proportional to u only. Again stopping time t1 by t2 equal to u1 by u2. These two are very very important one. Okay, there is a car race is going on. There this kind of questions are important. Car race is going on, so that both the cars started with an initial velocity what you can say. Okay, this we will discuss in relative motion topic, so this is about that one. And next you can take vertically upward motion, upward motion vertically upward motion vertically upward motion. In vertically upward motion, one of the very important point which you need to remember, h max equal to u square by 2g and h proportional to u square, h proportional to 1 by g. This you need to remember. Time of ascent equal to u by g. That means time of ascent is proportional to u. Time of ascent is inversely proportional to g. Why I am saying inversely proportional to g mean g on moon equal to 1 by 6 times of g on earth. Sometimes they will ask questions like this also. Time of flight equal to 2u by g. One of the very very important, air resistance in absence of air resistance. If air resistance is 0, time of ascent equal to time of descent. If air resistance is considered, air resistance is considered, if air resistance is considered, then we can say that time of ascent is less than time of descent. Time of ascent is less than time of descent. Ta equal to mu by mg plus r, where r is the reaction force by the air resistance. Sometimes they will give r is like 1 by 4 times of mg, like that they will say. This next time of descent equal to mu by mg minus r. We know that mg plus r is greater than mg minus r. More the denominator, less will be the fraction, so time of ascent is less than time of descent. So this is about the time of ascent and time of descent. How the time of ascent varies, the same way maximum height also going to be vary. This is about this particular case. Next, freely falling body. Free and here vertically upward motion, when the body is moving in upward direction and reaching the maximum height, again coming down. If you are taking a particular point a, for suppose a, at a while going up, at a while going down, the body had the same velocity. While going up and while going down, in both the cases the body had a same velocity, and the distance traveled by the body in last 1 second is equal to distance traveled by the body in first 1 second, that is equal to half gt square only. Next, freely falling body. For freely falling body, object is falling freely such that initial velocity equal to 0, h equal to half gt square we can write. Time of descent t equal to root of 2h by g we will write. Final velocity before hitting the ground is root 2 gh because a equal to plus g here. Total displacement is h. So v square minus u square equal to gh, v equal to root 2 gh we can write. This is about a freely falling body. For freely falling body, ratio of the heights taken by the body in 1 second, 2 second means 1 square is to 2 square is to 3 square is to so on. Ratio of the body, ratio of the heights taken by the body in first second, second means 1 is to 3 is to 5 is to 7 so on we will write. Next, for suppose this is a freely falling body, it is falling from certain height and they will say that it is falling from certain height h. There are certain points are there a and b. It taking the time t1 to comes to a, taking the time t2 to comes to b. Then what time it takes to move from a to b, that is t2 minus t1. T2 nothing but what, let you take this height is h2, let you take this height is h1, then this is root of 2h2 by g minus root of 2h1 by g, which is root of 2 by g into root h2 minus root h1. This is time taken by the body to cover first meter, second meter, like that means time ratio of the time taken by the body to cover first meter, root 1 minus root 0 is root of 2 by g into root 2 minus root 1, like this is root of 2 by g into root 3 minus root 2, like this we can cancel, so they will get this answer. This is about the freely falling body. And another important point in this case, that it is body is falling freely. Okay, let this basically you can cover up this particular point. Here one of the very important concept, next one is relative motion. In relative motion, the relative motion you can observe the relative motion. In relative motion, for suppose a car had the displacement x1. First car had the displacement x1. Second car B had the displacement x2. Velocity v1 vector, velocity v2 vector, acceleration a1 vector, acceleration a2 vector, taking the time t. And in this case, relative displacement x12 vector equal to x1 vector minus x2 vector, x21 vector equal to x2 vector minus x1 vector, v12 vector equal to minus of v21 vector, a12 vector equal to minus of a21 vector. And here one of the very important point, modulus of v12 vector equal to modulus of v21 vector equal to root of v1 square plus v2 square minus 2v1 v2, 2v1 v2, 2v1 v2 cos theta. If both the vehicles are moving in same direction, relative velocity is v1 minus v2. If both the vehicles are moving in opposite direction, relative velocity is v1 plus v2. If both the velocities are moving perpendicular direction, root of v1 square plus v2 square. This is about it. This can applicable for displacement also. x1 minus x2 same direction, x1 plus x2 in opposite direction, root of x1 square plus x2 square when they are moving in perpendicular direction. Similarly a1 minus a2, a1 plus a2, and like this we can do this one. And next, here one of the question is there, that it is one body is falling freely. One body is falling freely. At the same time, simultaneously, another ball is projecting up with an initial velocity u. The initial separation between them is h, where they will meet. Let they are going to meet here after some time t, and h1 height from the ground or h2 height from the top. Then here time to meet, time to meet, time to meet, we will write it as time to meet, we can write it as initial separation means initial relative displacement by relative velocity. Initial separation is what? This is x1 h1, this is h1 height, this is h2, but this is upward, this is downward. x12 equal to h1 plus h2, which is equal to h only, so h by u we will write, because u1 and u2 are moving in opposite direction, where u1 is 0, u2 is u, so the time in which they will meet is h by u. And next they will ask, At what position they are going to meet. From the ground means h1 equal to u t1 minus half g t1 square. This is t1. Next, if they are asking from find from top means what, h2 equal to half g t1 square. So like this we can calculate the time in which they are going to meet. And one of the very important point here, upward vertically upward projection from top of the tower. One ball, here we had a tower whose height is h. A ball is projected into air with an initial velocity u in upward direction, reaching maximum height, going up and reaching maximum height here. We know that A, B, C, D, displacement in the direction, total displacement equal to, we write AB minus BC minus CD we can write. So here total displacement equal, this two cancel, minus h we will get. So minus h equal to ut minus half gt square, such that h equal to ut minus ut plus half gt square we will write. This is very important formula once. And there is a balloon which is rising up. When the balloon is at a height h, stone is ready to fall. When stone is ready to fall, stone initially start to move with balloon in upward direction, so again fall. In this case also we will use this particular formula. Here t equal to u plus root of u square plus 2gh by gr. This is the formula. Time taken by the body to strike the ground is u plus root of u square plus 2gh. Root of u square plus 2gh is the final velocity. So t equal to u plus v by g. This is the one. This is the particular case, and you can understand this particular point. Now, another important application which is based on this particular concept that you can write it is, there is a tower. From this tower, a ball is dropping freely, so that it taking time t. From this tower, a ball is throwing in downward with an initial velocity u, so it taking time t2. A ball is projecting in upward direction, so going up and coming down, so it taking time t1. And here beta you can understand, I already told here, here also initial velocity u only. While going and coming at a particular point, while going up and coming down, it had a same initial velocity. So third ball is taking some extra time compared to second ball, that it is what, t1. T1 is greater than T2. The T1 minus T2 equal to time taken by the ball to move from here to here. This is maximum height. Let it 2u by g. 2u by g. Then initial velocity u equal to, we write it is g by 2 of T1 minus T2. We will write. This is the formula for initial velocity. Next, they will ask you to find h. You can take h for anything. H equal to, for downward projection, ut plus half gt square we can write. And here h equal to u value is what, g by, this is t1, t2 time is taking, t2, this is t2, g by 2 of t1 minus t2 into t2 plus half g t2 square. This answer you will get half g t1 t2 you will get. And next here t equal to root of t1 t2 you will get better. This is the important one. So this is the case. By this, like this you can able to solve the questions. And in the kinematics, most important point, graphs. One is st graph. st graph, this is s not changing, means velocity is 0. And here this is the st graph. It is what, st, it is like y equal to mx, that nothing but s equal to vt, that means velocity is constant. But at this type of questions you have to write a tan theta equal to velocity, slope equal to velocity, which we can write ds by dt also. Next, if the graph is like this, it, in this case the slope is increasing, as it is moving up. So this case we can write s equal to ut plus half at square, this one. Next, vt graph, if you are taking, this is vt graph. This vt graph represents that velocity is constant here, so acceleration is 0. And this vt graph represents that velocity is changing but acceleration is constant, but u equal to 0. This represents that This represents that v equal to u plus ad. And next at graph, if you take, this is uniform acceleration, this is uniform deceleration. If acceleration is changing, then slope of acceleration is called as the jerk we can observe in while traveling in a train. So there is a one particular question. This is, we had a velocity graph beta here, velocity graph, vt graph. In this velocity graph, this is figure 1, this is figure 2. If they are asking you to find distance, area above the time axis, plus area below the time axis. But displacement depends on direction. Area above the time axis minus area below the time axis. This is displacement. And next, acceleration graph is there, and slope of vt graph, dv by dt equal to acceleration. Acceleration graph is there. Area under the acceleration graph is velocity. Slope of acceleration is jerk. For freely falling body, for vertically upward projection, the graph will be like this. Initially velocity is there, finally velocity is 0. Then area under this graph is called as what? Maximum height. Then next, for freely falling body, v equal to root 2gh. So v square equal to 2gh, quadratic equation, v and h relation, that it is initially velocity means negative y-axis. The velocity will be like this. If it bounces, it will go up. Next one, there is a well beta, a stone is dropping into the well and strikes the water. A splash of sound here, sound is coming upward direction. The total time taken by the flash of sound is root 2h by g plus, because that is time of descent, plus time taken by the sound. Time taken by the sound is what? H by v, where v is the velocity of sound. This is also one of the important formula. And next here, another important point that regarding the vertically upward projection, we can write here. These graphs we got this, you need to remember that area above the time axis minus area below the time axis is acceleration. Area above the time axis plus area below the time axis is distance. This is about kinematics. Some other points, if anything is there, like one particular body is falling. Okay, let the remaining points you can cover up. These are the basic most important points. Okay.